All right, a couple of announcements as we prepare to move forward. First announcement, we're back to that hour and 5-minute time schedule. So 10:20 is the time that we will start. So I know a few people were confused after last week's shortened schedule, but we will be at 10:20 until 12:05 is our scheduled time. And in person no longer follows the cohort A, cohort B schedule. Online does, however, just like in the past, if you would like to attend the other cohorts in Zoom class, you certainly can. Just because it's not your class doesn't mean you can't be there. But you will still need to do the attendance question for the day. So just being in class won't count for your attendance for that day through the office. So make sure you do that. We will also, I will still record and post recordings. And then obviously you are still responsible for work done both in Monday's class and in Thursday's class. So this week we're going to take a look at 9.2, solving quadratic equations by factoring, and 9.3, which is solving using square roots. Actually, I think 9.3 is just simplifying square roots. So we're on page 10 in the yellow packet is where we're going to start today. If you need a calculator, you certainly can use one. Again, use one of the links, use the app, or if you have the Chromebook from the school, the TI-84 app is actually preloaded on that machine. Missing work from 8.4 to 8.6, which is found in the Chapter 8 folder on Schoology, is due by this Wednesday. And the 9.1 and the factoring review is in the Chapter 9 folder. Again, as much as you can, try to stay up to date and current with getting your homework in. So today we're going to do the 9.2 note check and homework. On Thursday, I will present the 9.3 note check and homework. If you can get today's homework done by Wednesday and the 9.3 homework done by Sunday, you'll be in great shape, or sooner, obviously. All right. So today we are going to look at solving quadratic equations by factoring. That is why last week we spent some time reviewing how to factor quadratic expressions. One of the most important parts of solving quadratics by factoring is this thing called the zero product property. For all real numbers A and B, and for all expressions A and B, A times B equals 0, then either A is 0 or B is 0. So what we're going to do with our quadratic equations, we're going to get them set equal to 0, factor if we can, and then set our factors equal to 0 and see what value for x gives us a solution based on the zero product property. And the reason we use the zero product property, every other number, there are an infinite number of ways to multiply to get any other number. So 0, that just one of the two things has to be 0. So what we will try to do is get our quadratic equation in standard form. So that's the form ax squared plus bx plus c equals 0. And we're being very specific here where a is not 0. So we have to have an x squared term. Otherwise, it's not a quadratic equation anymore. Then it becomes linear. All right. So to find the solution to our equation, x minus 9 times 5x plus 2 equals 0, we're going to use the zero product property. We're going to take x minus 9. Either that has to be 0 or 5x plus 2 has to be 0. And now we solve for x. So we solve by undoing addition or subtraction. So undo the minus 9 by adding 9 to both sides. So there's one of our solutions. X equals 9 would make that whole expression equal to 0. The 5x plus 2, again, undo addition or subtraction. And then undo the multiplication or division. So negative 2/5 would be another solution. Again, yes, you can write that as negative 0.4. Same answer. So if I plugged in negative 2/5 to that equation, I would get 0. All right, here's another equation. 3 times the quantity 2x minus 7 times x minus 3 equals 0. We're going to set each factor equal to 0. So 3 equals 0, 2x minus 7 equals 0, x minus 3 equals 0. Now, can 3 ever equal 0? No. So this is not going to give us any solution. Okay? But we want to get used to putting that greatest common factor equal to 0, because we could have a variable part to that that actually could give us a solution. 2x minus 7 equals 0. So now we're just solving two linear equations, 1 and 2 step equations that you may remember from Algebra 1. So undo the subtraction by adding, undo the multiplication by dividing. And you can certainly leave that as 7/2. That would be fine. Some might like it as a decimal. You could also go 3 1/2. I prefer just leaving it as the decimal answer. This makes it a little bit easier. The other solution, if I add 3 to both sides, I get x equals 3. So there are my two solutions. X equals 3, x equals 7/2. All right. So now I'm going to give you a minute or two to go ahead and attempt these couple of equations, find the solutions. All right. So again, using the zero product property, we go 2x minus 1 equals 0, x plus 3 equals 0. For the first factor, add 1 to both sides, divide by 2. Again, you could put 0.5 there as well. For the second factor, subtract 3 from both sides, and we get that solution. Example number 2. Again, we'll subtract 1. Again, the fraction answer works great. Otherwise, we do have that decimal answer, negative 0.25. The second solution, undo the subtraction by adding. Undo the multiplication by dividing. And again, either the fractional or decimal answer. All right, so hopefully this seems pretty straightforward. Now, we're gonna up the ante a little bit. All right, so on the top of page 11 in your packet, write the quadratic equation in standard form. So we have it equal to 0. Have to do that first. As the little bullet point says there, the equation must be set equal to 0 before you can factor it. Factor the quadratic equation using the x method, if a is equal to 1, or the slide method if a is not equal to 1. And finally, use the zero product property to solve the equation. All right, so first thing we need to do, get this equation equal to 0. So we have that negative 20 on the right-hand side of the equation. I would add 20 to both sides. Excuse me. Our x squared, we have a value of 1, so that's nice. We can then use our x method, find two numbers that multiply to positive 20 and add to positive 9. Again, if you're not sure, start with 1 and the number. And then check, 1 plus 20 is not 9. 2 plus 12 is not 9. 3 is not going to be a factor. 4 plus 5 is 9. A very common mistake that students make is they get to the factor part and then they say, okay, my answer is 4 and 5. And they are not. They forget that we then need to take each factor and set it equal to 0. And so our solutions for this equation is x equals -4 or x equals -5. Those would make the equation true. Letter B, we have x squared plus 25 equals 10x. Again, first thing we want to do, get it in standard form so that it's equal to 0. So I'm going to subtract 10x from both sides. And I can't do anything to simplify on the left-hand side because I don't have any like terms. So I can't say like x squared minus 10x is negative 9x, or negative 10x plus 25 is 15. That doesn't work. They're not like terms. On the right-hand side, the 10x minus 10x, that I can combine to get my 0. And now I can factor. Again, two numbers that multiply to 25 and add to negative 10. So I know they both have to have the same sign, and they're both, in this case, going to be negative so that they add to that negative 10. So let's see, negative 1 and negative 25. No, that does not add to negative 10. 2 is not going to be a factor because 25 is not even. 3 is not going to be a factor because if I add 2 plus 5, I get 7, and 7 is not evenly divisible by 3. 4 is not a factor because, basically because 2 is not a factor, 4 can't be a factor. And then our next one would be 5. And 5 is a factor because 25 ends in a 5. And there's my answer as far as my factor goes. So this is a perfect square trinomial. They have the same factor. The nice thing about these is then you'll only have one solution. If I add 5 to both sides, I get x equals 5. So it doesn't make sense to say x equals 5, x minus 5 equals 0, or x minus 5 equals 0. That's going to give us the same solution. We only need to write that solution one time. All right. And again, if you recognize that it was a perfect square trinomial, you wouldn't have had to use the x method. But if you didn't recognize it, the x method works really well. All right, another one, solve by factoring. So now we have a number in front of our x squared. The first thing I would do, look for a greatest common factor. Is there a number other than 1 that evenly divides into 3, 10, and 8? No. So then I use the slide method. Take the 3, slide it over, and multiply. Minus 8 times 3 is minus 24. Now it looks like that X method type problem. So I'm going to look for two numbers that multiply to negative 24 and add to positive 10. So now they multiply to a negative, so we have to have one positive and one negative value. And they add to a positive, so our larger factor has to be positive. So negative 1 and positive 24, add them together, I get 23, not 10. So that's not going to work. Negative 2 and positive 12, add those together and I get positive 10. That's the pair I'm looking for. But then remember, to get that pair, I ended up multiplying by 3. So now I need to divide by 3 to get my final solutions. Two is not evenly divisible by 3. And the only number that evenly divides into 2 and 3 is 1, so we can't reduce it. So that 3 is going to go in front of our x. In our other factor pair, 12 divided by 3 is 4. And then we need to use our zero product property. So just that one extra step today from what we did with our factoring review. Add 2 to both sides. Divide by 3. So one of our solutions is 2/3. And here's one reason why I like the fraction. If I try to put that in as a decimal, it's 0.6 repeating. And it's kind of hard to type that in as an answer on your computer. Okay? So 2/3 is a fine answer. On the other factor, we subtract 4 from both sides, and we get x equals -4. All right, another couple that I want you to try. Again, I'm going to give you just a couple of minutes to work on them, and then we will take a look at the solutions together. But go ahead and begin them on your own. All right. So again, we want to get these so they are equal to 0. So I would subtract 64 from both sides. I want to find two numbers that multiply to -64 and add to -12. So they multiply to a negative and add to a negative. That means my larger of my two factors is going to be negative. That doesn't add to negative 12. So then I try 2 and negative 32. That doesn't add to negative 12. 3 is not going to divide into 64 because 6 plus 4 is 1, 1 is 10, 1 plus 0 is 10 is 1, and 3 doesn't divide evenly into 1. 4 will divide into 64. Nope, that's wrong. 16 times, and if I add those together, I do get negative 12. Set both of my factors equal to 0. In this case, I subtract 4 from both sides, so x equals negative 4. For the second factor, add 16 to both sides. And we have our solutions. Number 2, again, first thing I'm going to do, because I have that 2x squared, I'm going to check to see, is there a greatest common factor? In this case, there is not. But always remember to check. So then take that 2 and slide it across. Six times 2 is 12. Now use that x method, two numbers multiply to 12 and add to 7. Both positive, so both of my factors will be positive. 1 and 12, they add to 13, not 7. 2 and 6 add to 8, not 7. 3 and 4 add to 7. X plus 3 times x plus 4 equals 0. Set each factor equal to 0. And now solve each of those mini equations. Undo addition by subtracting. Undo addition by subtracting. And we have our two solutions, x equals negative 3 and x equals negative 4. Right, one other application for factoring is graphing by factoring. So we have f of x equals x squared minus 2x minus 8. To graph this using factoring, what I'm going to start with is x squared minus 2x minus 8 equals 0. I'm going to solve that related equation. Excuse me. So I need to find two numbers that multiply to negative 8 and add to negative 2. Again, they multiply to a negative, so I'm going to have a positive factor and a negative factor. They add to negative 2, so my negative factor has to be the larger. So 1 and negative 8, that adds to negative 7. 2 and negative 4, that adds to negative 2. That's what I want. So now it's in that intercept form. So if I find the solutions, undo addition by subtracting, x equals negative 2. That's one of my x-intercepts. x minus 4 equals 0, add 4. X equals 4 is my other x-intercept. So x equals -2, x equals 4. I'm going to find the axis of symmetry, and that's halfway between my intercepts. So my axis of symmetry, I know it says vertex there, just a typo. I take -2 plus 4 and divide by 2. -2 plus 4 is 2. 2 divided by 2 is 1. So my axis of symmetry is at 1. Then I'm going to find the vertex. And remember, to find the vertex, I take 1 and plug it in for x in my original equation. So I'm going to have 1 squared minus 2 times 1 plus 8. Nope, sorry, minus 8. Okay, yeah, minus 8. Sorry. So 1 squared is 1, minus 2 times 1 is minus 2, minus 8. That gives me the y-coordinate of my vertex is -9. So 1, -9. And it might be good to plot one other point. We know the y-intercept is -8. So that's going to go there. And we'll have the mirror image point there. And we should be able to, again, if you're asked to graph these in your homework, that's all you need to graph. Don't try to sketch in the parabola. I think it's difficult to do that, and I don't want you to worry about it. So there's our parabola. All right, again, another try now. I'm going to give you a few minutes to try it, and then we'll get together and talk about it. All right, so again, factoring by graphing by factoring. So we're going to take x squared minus 6x plus 8, set it equal to 0. Factor, find two numbers that multiply to 8 and add to -6. Because they have to multiply to a positive value, they have to have the same sign. And they have to add to -6, so both numbers are going to be negative. So start with -1 and -8. Those do not add to -6. They add to -9. Then try -2 and -4. Those do add to -6. Find my solutions. Those will be my x-intercepts. X minus 2 equals 0. I undo the subtraction by adding 2 to both sides. So one of my y-intercepts is x equals 2. X minus 4 equals 0. I add 4 to both sides. My other x-intercept is x equals 4. Next, I'm going to find the axis of symmetry. Now, my guess is at least one of you can look at that and tell me exactly the value that's halfway between 2 and 4. Hopefully all of you can, but I will show the work. Take 4 plus 2 and divide by 2. 4 plus 2 is 6. Divided by 2, my axis of symmetry is at 3. Vertex. I'm going to take the original function. So I get 3 squared, plugging 3 in for x, minus 6 times 3 plus 8. Be 9 minus 18 plus 8. 9 minus 18 is -9, plus 8 is -1. And again, I could go to my y-intercept, which is that value right there, 8, and plot that point. Again, no need to draw it in on the computer, just because it's very difficult to do. And I want to see the points that you come up with. All right, so there is your notes for the day. I will set up breakout rooms. Again, we have our normal